Let's start this section by graphing some exponential functions. Since we don't yet know any special properties of exponential functions, we will graph using a table of values. Example 1, y equals 2 to the power of x. Let's create a table of values. As you can see, list 1 is my x, list 2 is my f of x, or my y. 2 to the first power is 2, 2 to the second power is 4, 2 to the 0 power is 1, and so on. When we plot the points on the coordinate plane, we get the following graph. Exponentials always have this basic shape. That is, they start very small, and then, once they start growing, they grow faster and faster. And soon they become extremely big. You may have heard people say that something is growing exponentially. This implies that the growth is very quick. An exponential function actually starts slow, but then grows faster and faster all the time. Specifically, our function y equals 2 to the power of x doubles each time we increase x by 1. Let's graph another example. Let's try y equals 3 times 2 to the power of x. Let's also see if we notice a difference from our previous graph, which was y equals 1 times 2 to the power of x, or simply y equals 2 to the power of x. So again, let's make a table of values. And here's the table of values. We can see that for list 1, which is x, list 2, f of x. Let's take a look at that point there. Y equals 3 times 2 to the power of 3. Y equals 3 times 8. Y equals 24, which matches what we find here. Now let's graph this function, y equals 3 times 2 to the power of x, but we will also graph y equals 1 times 2 to the power of x to see if there's a difference. Here are the graphs. You can tell by the point here that we are dealing with y equals 2 to the power of x. This is the first graph that we looked at, which means that this highlighted curve goes with our new function, y equals 3 times 2 to the power of x. We can see that the function y equals 3 times 2 to the power of x is bigger than the function y equals 2 to the power of x. In both functions, the value of y doubles every time x increases by 1. However, in y equals 3 times 2 to the power of x, it starts with a value of 3, which we see here, while y equals 2 to the power of x starts with a value of 1. So this makes sense that y equals 3 times 2 to the power of x would be bigger as its values of y keep getting doubled.